Good evening, everyone. Myself, I'm Faaiz. I'm from AIIMS Nagpur. Okay, so our topic of discussion is electrostatics. Okay, so I'm directly getting into the topics. First, we will talk about specific properties of the charge. See, charge is a scalar quantity. First point, charge is transferred. Charge is always associated with mass. Charge is quantized. Right? Yeah, is equal to any. Then charge is conserved. Charge is invariant. When accelerated charge radiates energy, then charge has attraction repulsion. Okay. Yeah. Next, Coulomb's law. We all know that Coulomb's law. What is Coulomb's law? F is equal to K Q1 Q2 divided by R square, where R is a distance between Q1 and Q2, and K is equal to 1 by 4 pi epsilon, and it's equal to 9 into 10 raised to 9 Newton meter square per Coulomb square. Okay. And Coulomb's law in terms of position vector, if suppose Q1 is at R1 vector and position of Q2 is R2 vector, then the distance between Q1 and Q2 will be R1 minus R2. So in terms of position vector, F1 2 is equal to K Q1 Q2 divided by, yes, magnitude of R1 minus R2 cube whole cube into R1 minus R2. Okay. So this is our first PYQ. Yeah. So see, I'm reading in the question. Two identical conducting spheres A and B carry equal charge. They are separated by a distance much larger than their diameter. Okay. And the force between them is F. A third identical conducting sphere C is uncharged. Sphere C first touched to A, then to B, and removed. As a result, the force between A and B would be equal to 2018 question. Okay, can easily solve this. How? See, what is the condition? See, we have two spheres, sphere A and sphere B. Okay, with identical sphere, each has charge QQ, no doubt. Okay, then a identical sphere C. This is an identical sphere C, which is uncharged, means charge of C will be 0 and A is Q. It's touched. C touched to A. So what will happen? Yes, charge will transfer from A to C. So finally, A's charge will become Q by 2 and C's charge will become Q by 2. Simple. Okay. Then then to B. Then the C sphere is resting to B. So second condition, this is our sphere B having charge Q. Okay, having charge Q. And now it is touched with the sphere C having charge Q by 2. So finally, this is our B, this is our C. Charge will transfer such a way that what is Q plus Q by 2? Q plus Q by 2 is how much? 3Q by 2. Half of 3Q by 2 is 3Q by 4. So B will get 3Q by 4 charge and C will get 3Q by 4 charge. Okay. What's the question? Force between A and B would be equal to. It's that force between A and B is F. That means if they are separated by distance R, F is equal to A Q square divided by R square. Okay. Simple. Then as a result, okay, last in final condition, A's charge is Q by 2, B's charge is 3Q by 4. So force will become F dash is equal to K into Q by 2 into 3Q by 4. The distance remains same. So KQ by R square into 3 by 8. So F dash equal to 3F by 8. Yeah. So option D will be the correct answer. Okay. Simple question. Yeah. Next. Next question. Two charges each equal to Q are kept at x is equal to minus A and x is equal to A on the x-axis. A particle of mass m and charge Q0 which is equal to Q by 2 is placed at the origin. If charge Q0 is given a small displacement, the displacement is very much less than the distance A along the y-axis, the net force acting on the particle is proportional. Okay, see, this is the condition. Okay, on x-axis, at A distance, Q, here also minus A, Q. Okay, no doubt. So, if Q0 is given a small displacement Y. So, Q0 is here. Okay, so see, so between Q and Q0, force will be towards F and this direction also F. Okay, this both Q will repel the Q0. Okay, if this angle is theta, and this is also theta. Same, this is also theta, this is also theta. Okay, so see, here F sin theta component will cancel each other. See, okay, along the y direction. So the net force will be 2F cos theta. Net force will be 2F cos theta. So F net on Q0 will be 2F cos theta. How? See, here will be F sin theta and F sin theta. This F sin theta will cancel each other. Easy? Yes. Next. So the F net on Q0 is 2F cos theta. And what is F? F will be A Q0 divided by distance will be here to here. This is a distance. If this is y and this is a, this will be root of a square plus y square. Simple. Root of a square plus y square whole square. So that will be a square plus y square only. A square plus y square. A square plus y square. And cos theta. From this triangle, cos theta will be adjacent side by hypotenuse. Y divided by root of a square plus y square. Easy. So the F net will be 2F cos theta. So 2 into F is Q0 divided by a square plus y square into cos theta is y by a square plus root of a square plus y square. Easy. So finally we can write like 2KQ0y by a square plus y square whole raised to 3 by 2. Right. And it is given as y is very much less than a. So if y is very much less than a square plus y square approximately will be equal to a square only. So F net will be 2KQ0y divided by a square into a square raised to 3 by 2. That will be a cube. So A is constant again. So see, so F net we got as 2k q0 by A cube into y. So actually F net proportional to y. Okay. So A will be the answer. The question is the net force acting on the particle is proportional to y. Option A is the correct answer. Okay. Next question. What is next question? It's actually very simple question. Four charges Q1, Q2, Q3, and Q4 of same magnitude are fixed along the x-axis. X is equal to minus 2a minus a minus 2a minus a plus 2a respectively. A positive charge Q is placed on the positive y-axis at a distance b is greater than 0. Four options of the signs of these charges are given in list 1. Okay. See, in list 1 it is given as like PQRS. Four options are there. In each option, the signs of the Q1, Q2, Q3, Q4 are different. Okay, so we have to direction forces is given in list. So we have to match with list 1 with the list 2. So this is, yeah, almost as the previous question. Okay, see, so this is the condition. This is the condition. This is the condition. See, here we have Q. Okay, E, see, see the first option. If Q, Q2, Q1, Q3, Q4 are positive, if all are positive, 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 if all are positive, then yeah, force will be okay. Net force will be along. See, this will also repel. This will also repel. So net force will be along y-axis. Net force will be along y-axis, along positive y-axis. So P should correspond to option 3 positive y-axis because all positive charges will repel. So P3, see these options we can cut. So A or C is the answer. So next C. So Q is given in common. So we are taking R. Q1, Q4 positive. Q1, Q4 positive. Okay, Q is there. Q1, Q4 positive. This is positive. This is positive. Q1, Q4 positive. Q2, Q3 negative. Okay. Q2, Q3 negative. See, this is the condition. Then this positive charge will repel. Okay. And this negative charge will attract. And here also negative charge will attract. This positive charge will repel. But see, here actually, see, this distance, see, these positive charges are located more distance than these negative charges, no? So force is inversely proportional to distance, square of the distance. So if distance is more, force will be less. So actually, this force will be, yeah, the repulsion force is lesser compared with the attraction force by negative charges because the distance is less. The distance is less as compared to positive charges. The net force will be along. Net force will be along this. That means net force will be along minus y-axis. So R is correspond to 4. So P3 R4 option A is the correct answer. Option A is the correct answer. Okay. Easy. Yes. Next. Next. C. Next C. Stable and unstable equilibrium. See, this concept. See, in a ball, if I put mass M here, okay, then I changed its position to here. Okay. So what will that mass do? Mass will again come to bottom position. Mass wants always to be at the bottom position. So this is called a stable equilibrium. We can say that this mass is at stable equilibrium. See, in this case, if I release it this mass, this particle, this object will run away from the starting point. The particle doesn't want to stay at the starting point at the top. So this is actually unstable. Yeah, this is the unstable equilibrium. This here is the stable equilibrium. See, the same scenario we can apply in electrostatics. How? See, in a line, two charges are here, QQ. Okay, same positive charges, positive charge. And here Q0. Q0 will be in stable or unstable. Which equilibrium? See, F this direction. And because of this QF is this direction. So net force is along this direction. Q0 is tries to run away from its position. So actually this is unstable equilibrium. This is unstable equilibrium. And see, in this case, here we have a Q and we have a Q. Okay, two charges I'm placing, each with positive charge. And along the same lane from origin, I'm just shifting Q0 towards one charge. So what will happen? So this positive will ripple. See, if charge is present at present, if charge is here, yeah, this will ripple. Repulsion force will be higher P. This repulsion force will be repulsion due to this force. This charge will be higher because distance is less. So net force will be along minus x-axis. That is the particle. Yeah, particle tries to reach at its original point, its starting position. That is the charge is at stable equilibrium. Yeah. Again, basic concept. Force is inversely proportional to distance. Stable equilibrium. Okay. Yes. Next. Next question. Two balls of same mass and carrying equal charge. See, two balls, same mass and same charge, are hung from a fixed support of length L at electrostatic equilibrium. See, electrostatic equilibrium, yeah. Assuming that electrostatic equilibrium means the negative force will be zero. Assuming that angles made by each thread is small. Hmm. Yeah, the angles are very small. The separation x between the ball is proportional to yeah, the proportionality. You have to find out the proportionality. See, again, a very easy question. First, this is the condition. So, a length, yeah, we have two masses are here, same mass and same charge. The distance between the charges is x. Distance between the charges is x. And I am taking this angle as theta. Okay. It's given as angle made by each thread is small. Okay, keeping that in mind. So if theta is small, we know that what? If theta is small, if theta is small, sine theta, which is equal to tan theta, and which is equal to theta. We all know that. Okay, keeping that in mind. Yeah. So see, I'm taking this mass. Okay. The force acting on that mass. Okay. I'm drawing that forces. So downward direction, mg will be the easy, and towards this direction, repulsion force from this q will be present, kq square by x square. And see, so this is a normal, this is also theta. Okay. So along the thread, tension will be there. Okay, now we can resolve the tension. So along this T sin theta, along this T cos theta. So just equate. T sin theta equal to T sin theta will balance against kq square by x square, and T cos theta equal to mg. Simple. So dividing first equation with the second equation, tan theta will be kq square divided by x square mg. Kq square by x square mg. Easy. And from this triangle, from above triangle, this is theta, this is x by 2, this is L. Okay, right. What will be sine theta? Sine theta equal to x by 2L is equal to tan theta, because theta is very small. So we can equate x by 2L for tan theta equal to kq square divided by x square mg. Okay, so taking x square to left hand side, so x cube equal to kq square 2kq square by mg into L. That is x cube proportional to L. Question is x between the balls is proportional to x proportional to L raised to 1 by 3. So option D will be the correct answer. Easy. Yes. Next. Next question. Again, similar question. Two identical charged sphere suspended from a common point by two massless strings of length L are initially at a distance D. There was distance x. See, previous question distance was x. Here distance is D. Apart because of their mutual repulsion, the charge begins to leak from both the spheres at a constant rate. Okay, charge begins to leak. As a result, charges approach each other with a velocity v. Why? Because if charge is leaking, yeah, the repulsive force will decrease. That's why charges are approaching with velocity v. And as a function of distance x between them, okay, we have to find out that approaching velocity and x relation. We have to find out this relation. Yeah, we have to find out that relation. And see, okay, from this question, we know that x cube equal to 2k cube divided by mg L. Okay, we know that. So this is also same condition. So we can equate x cube is equal to 2k cube divided by mg into L. Okay. Why did I write the same question here? Because both, see, previous question also and this question also, these are same questions. Here what is happening? Here the charges is leaking. Okay, with a set, okay, charges are leaking. That's why that both charges are approaching each other with a velocity v. That's all. Simple. So we know from this question k 2k q. Let me confirm once again. 2k q square. Okay. Yes, 2k q square. So x cube directly proportional to k q square. Okay. So x is directly proportional to q raised to 2 by 3. Easy. If I differentiate x dx by dt directly proportional to 2 by 3 into 2 by 3 into q raised to 2 by 3 minus 1 dq by dt. Easy. So this will be velocity proportional to 2 by 3 q raised to 2 by 3 minus 1 will be minus 1 by 3, right? Minus 1 by 3. So velocity, we got relation velocity proportional to q raised to minus 1 by 3, and we know that q is from this relation we know that q is proportional to x raised to 3 by 2, right? So we can equate here. So velocity proportional to, for q we can write x raised to 3 by 2 raised to minus 1 by 3, right? So velocity proportional to x raised to 3 will cut each other, minus 1 by 2. Yeah. So velocity will proportional to x raised to minus 1 by 2. So answer will be option D, velocity proportional to x raised to minus 1 by 2. Easy. Again, a very easy question. Same question, but in this question, it's asked that relation between x and the length of the thread. But in this question, the approaching velocity with the distance between charges. Easy. Next question. A charge q is placed at each of the a charge q is placed at each of the opposite corners of a square. A charge q, small q, is placed at each of the other two corners. The net electrical force on capital Q is 0, then Q by Q. We have to find out Q by Q ratio. So again, you can draw the diagram. So this is the condition. Suppose capital Q is here, capital Q is here. A charge Q is by each of the opposite corner, and small q is Q. Okay. So net electrical force on Q is 0. So net F net here will be 0. After that, the Q by Q ratio is asked. So see, if the small q's are positive, then see, the net force will be along this direction. So the net force will never equal to 0. So this small q's must be minus negative charges. That's a logic. Okay. And the length of the square is L. So FQ same FQ will act this direction, and repulsive force will act because of this capital Q. Okay, F capital Q. So here will be net will be root 2 FQ, because root of F square plus F square, root of 2F square, that is root 2 FQ. So FQ will be equal to, FQ means repulsive force because this charge Q, capital Q, and F small q means attractive because of this small charge Q. FQ will be how much? If this is L, this is L. See, this is a square, and this is L, this is L, this is L. So this distance will be root of L square plus L square. That is root of 2L square. That is root 2L. So K Q square will be root 2L whole square. That is 2L square equal to root 2. FQ will be KQQ divided by L square. So we can cancel this L square, 1Q and K also. So Q by 2 will be root 2Q. And it's the question is capital Q by small q ratio will be 2 root 2. Yeah, minus 2 root 2 because Q is positive and this small q is negative. So minus 2 root 2. So option D is the correct answer. Okay, easy. Yeah, next question. Yeah. Again, a very simple question. Three charges minus Q1 plus Q2 and minus Q3 place as shown in the figure. The x component of the force on minus Q1 is proportional to. So we have to find out the net force acting on the minus Q1. No, not net force, x component of the net force. So simple. See, let me draw the diagram. So yeah, here we have minus Q1, Q2, distance B, the distance A, and minus Q3. So because of this Q2, yeah, attractive force will be there along this axis. Right. Okay. And because of this minus Q3, repulsive force will be there. Repulsive force along this direction. Okay. Easy. If suppose this is F12, this will be F13. See, force on 1 due to 2, force on 1 due to 3. And it's given as this angle is theta. That angle is theta. This angle will be theta. So this angle also will be theta. So the x components will be x components will be easy. X component will be F12 plus F13's sine component. F13 sine theta. So proportionality. See what is F12? F12 will be K Q1 Q2 divided by B square plus F13 will be K Q2 Q3 divided by A square into sine theta. So yeah, they just want the proportionality. So constants, we can remove the constants. So Q2 by B square plus Q3 by A square into sine theta. Q2 by B square plus Q3 by A square into sine theta. So option D will be the right answer. Easy. Very easy question again. Yeah. Next question. Yeah. Next, we can talk about electric field. What is electric field? Electric field is force divided by charge. Yes, force divided by charge. That is electric field is equal to F by Q. And for a point charge is equal to KQ divided by R square. Easy. Everyone knows this. Easy Q by R square for a point charge. And the electric field vector is equal to vector F by Q. Yeah. So the question, this is the question. Two point charges plus 8q and minus 2q are located at x is equal to 0 and x is equal to L respectively. So this is x is equal to 0 and this is x is equal to L. 2 point charges at x is equal to 0 plus 8q and at x is equal to L minus 2q. Okay, the location of a point on the x-axis. Okay, the location of a point on the same axis. Location of a point on the same axis. Our net electric force, net electric field should be 0. Suppose I'm taking, so we have three possibility, right? We have three possibility. Here A, B, C. At AC, because of this 8q, electric field will be towards minus x. And this minus 2q will, because of this minus 2q, electric field will be towards this. This never will get cancel each other. Why? Because this larger charge at small distance and small charge at larger distance. So yeah, the by proportionality, this will never get cancel each other. So at B, C, at B, because of 8q, electric field will be towards this. Okay, because this minus 2q, yeah, this same distance only but different charges. Yeah, so it is never going to get cancelled. So at CC, because of this minus 2q, the distance is small. Towards a distance is small and charge is also small. So yeah, here is a possibility of cancelling each other. Suppose the point C is located at D distance from minus 2q, where the net electric field should be 0. Should be 0. Yeah, should be 0. We can simply equate because of 8q, k8 k into 8q divided by L plus D whole square. See, L plus D whole square is equal to k into 2q. Yeah, that will be opposite direction. K into 2q by D square. Easy. Yeah. So kq we can cancel for 1 by D square equal to 4 by L plus D whole square. So I'm taking square root on each side. 1 by D will be 2 by L plus D. That is 2D is L plus D. That is L is equal to D. L is equal to D. So distance from minus 2Q is L only. What is the question? Location of a point on the x-axis that is the net electric due to these 2 points are 0. So x is equal to 0 is here. So here will be at point C will be x is equal to L plus D, right? D is also L. So L plus L, which is equal to 12. So option B is the right answer. Easy, easy, busy question from electric field. Yeah. Next question. Charges Q1, Q2 are at points A and B. Yeah, at points A and B. The resultant electric field at point O is perpendicular to the hypotenuse. Though, yeah. So the resultant electric field will be towards this direction, resultant electric force, perpendicular to hypotenuse. Why outwards? Because positive charge is safe. Then Q1 by Q2 is proportional. I have to find out Q1 by Q2. Again, see Very simple question. Let me draw the diagram. Okay, we have Q2 here, we have Q1 here, and this is perpendicular to hypotenuse. So I am taking this angle as theta. Okay. Okay. So because of this Q1, this is a right angle triangle. So this distance I'm taking x1, this is x2. The electric field towards here k q1 square by no, k q1 by x1 square towards this k q2 by x2 square. Easy. This is theta. This is theta. This is 90. This is 90 minus theta. So this will be 90 minus theta. So this is theta. Okay. Easy. So tan theta which is equal to tan theta. See, from this triangle, tan theta will be equal to opposite side by adjacent side. So yeah, tan theta will be equal to k q2 by x square by k q1 by x1 square. This will turns out as q2 by x square. q2 by wait. This is x2 square. This is x1 square. So q2 by x2 square into x1 square by q1. Easy. And this is theta. From this triangle, we can write tan theta as x1 by x2, opposite side by adjacent side. So we got two equations for tan theta. So x1 by x2 equal to x1 square q2 x2 square q1. So see, x1 x2 we can cut each other. So 1 equal to x1 q2 divided by x2 q1. We have to find out q1 by q2. q1 by q2. So q1 by q2 is equal to x1 by x2. Answer is x1 by x2, option C. Easy. Yeah, x1 by x2. Easy question. Next, a small point mass m carrying some positive charge on it is released from an edge of a table. See, yeah, released from edge of a table. There is uniform electric field in this region in the horizontal direction. So see, I released a point mass which has mass m and charge q, and where electric field exists along positive x-axis, and gravity is acting downwards, positive minus y-axis. Okay, we have to describe the trajectory of the mass. Easy. So released means, see, I'm making two column. So x-axis what will happen, y-axis what will happen. Both axis initial velocity is zero. Both axis initial velocity is zero. On x-axis acceleration will be, yeah, here, because of electric field force will be QE. Electric field is F by Q. So acceleration will be QE by M. And here acceleration will be, yeah, G, acceleration due to gravity. So the trajectory along x direction will be ut plus half at square. So ut u is 0, half q e by m t square. Along y axis also, yeah, displacement will be half g t square. Easy. See, x is also proportional to t square. Y is also proportional to t square. If x is proportional to t square and y is proportional to t square, that means x is directly proportional to y. X is directly proportional to y. Which graphs suits this x is directly proportional to y? Yeah, only one graphs D. X is directly proportional to y. Simple question. Next, the next question. A simple pendulum of length L is placed between the plates of a parallel plate capacitor having electric field E. See, just okay. So electric field is so electric field. See, plus here's electric field. This is the direction of electric field. Okay, and we have a pendulum. Pendulum of length L, mass M, charge Q, and we know that. See, time period of a pendulum is 2 pi root of L by G. From this equation, see, if only acceleration due to gravity exists, time period of pendulum is equal to 2 pi into root of L by G. For other situations, if other situations, we can write 2 pi into root of L G effective. So here just we have to find out the G effective, as simple as that. G effective. For finding out the G effective, see this is free body diagram of the point mass M, mg acting downwards, and because of the electric field, force will be acting Q E by M. Easy. Q E by M. So the net force will be along this. So that will be root of mg square plus Q E by M whole square. Simple. This will be the net force. You have to find out the G effective. That means what is the acceleration. So net acceleration will be divided by mass root of. So G effective will be by dividing mass G square plus Q E by M. Easy. Any doubt? So we got G effective. So by equating that G effective here, yeah, we can simply say the equation no, not minus plus. So yeah, time period will be 2 pi root of L by G effective, where G effective is G square plus Q E by M whole square. Simple. Yeah. Yeah. Next question. This is our next question. A particle of charge Q and mass M subjected to an electric field, where electric field is given as E0 into 1 minus x square. In x direction, where a and E0 are constants, initially the particle was at rest. Okay, x is equal to 0. Other than the initial position, the kinetic energy of the particle becomes 0 when the distance of the particle from the origin is c. Kinetic energy of the particle. Okay. So we know that for acceleration, we know two equations. What are they? A is equal to dv by dt and A is equal to v dv by dx. So A is equal to dv by dt in terms of A is equal to v dv by dx in terms of x. So here we have to find out distance. Okay. So because of this electric field, F will be E0. If charge is Q, Q E0, 1 minus AX square. And the acceleration will be Q by Q E0 by M, 1 minus AX square. Easy. No doubt. Okay. Simply just F is equal to QE and acceleration is QE by M. And we can equate acceleration with V dV by dx. Simple as that. So V dV by dx is equal to Q E0 by M, 1 minus AX square. We simplify this equation. V dV by dx is equal to Q E0 by M minus Q E0 A by M x square. So integrate this. Okay, integrate this. So integrating this, we will get V dV by dx will be C. Yeah, we get V dV V square by 2 x minus x cube by 3. X cube by 3. Yeah, A into x cube by 3. Easy. So when the distance of particle originates. So see, if kinetic energy becomes 0, kinetic energy becomes 0 means I'm taking m this side. Okay, so m is square by 2. If it becomes 0, that means x is equal to ax cube by 3. That means 1 equal to ax square by 3. That means x square is equal to 3 by a. That means x is equal to root of 3 by a. X is equal to root of 3 by a. X is equal to root of 3 by a. Kinetic energy will be 0. So root of 3 by a, option C. Yeah. Next is electric field due to a rod having charge Q and lambda is Q by L. That means charge per unit length L. So electric field will be K lambda L by D into L plus D. And if it is placed perpendicularly, then at point P, which is making theta 1 with one end and theta 2 with other end, E perpendicular will be along perpendicular will be K lambda R into sine theta 1 plus sine theta 2, and along parallel will be K lambda R cos theta 1 minus cos theta 2. Easy. Yeah. And C R making theta. So E will electric will be 2K lambda by R sine theta by 2. See arc if that is a semicircle, theta will be how much? 180. So the equation is 2K lambda by R sine of theta by 2, 180 by 2, 90, and 990 is 1. So 2K lambda by R. This is 2K lambda by R. Okay. Next, ring. Because of ring, due to ring at axis, the distance x is equal to KQX divided by x square plus R square whole raised to 3 by 2. Yeah, at x is equal to R by root 2, electric field will be maximum. This is the graph. And due to disk, where sigma is surface density Q by area. Due to disk, electric field is at a distance x making angle theta sigma by 2 epsilon into 1 minus cos theta. Cos theta we can write as, yeah, x by root of s square plus r square. Yeah. So here is the question. For a uniformly charged ring of radius r, the electric field on its axis has the largest magnitude at a distance h from the center. The direct question. Yeah, this is direct question. I told you that. Yeah, a ring at x is equal to r by root 2 electric field will be maximum. Yeah, so the answer is option B. Answer is option B, r by root 2. Okay. Yeah. Yeah, here is the last question. Okay, this is the last. A thin disk of radius b is equal to 2a has a concentric hole of radius a, carries uniform surface charge sigma on it. The electric field on its axis, okay, at height h, and height h is very much less than a. We have to find out from, okay. See, for this type of questions, we have to find out electric field due to remaining, right? So E remaining will be electric field due to full minus electric field due to remove, as simple as that. So first we have to find out electric field due to full. Yeah, what is the equation? Sigma by 2 epsilon. Here is the equation. Sigma by 2 to 1 minus x by root of x square plus square. So 1 minus this h, this is 2a. So this distance will be root of h square plus 4a square. It is given as h is very small. So this will turns out as root of 4a square, that is 2a only. So 1 minus h by 2a, because h is very small, minus sigma by 2 epsilon, removed 1 minus h by a only. Okay. So by solving this, sigma by 2 epsilon, solving this, can write sigma by 2 epsilon minus, no, we can take sigma by 2 epsilon common. Okay, 1 minus h by 2a minus 1 plus h by a. Minus 1 plus 1 cancel. Sigma by 2 epsilon minus h by 2a plus h by a. Yeah, h by a minus h by 2a. H by a minus h by 2a. 2, 2. So sigma by 2 epsilon, how much h upon 2a? Right. So the answer will be sigma h divided by 4 epsilon a. Sigma h divided by 4 epsilon a. Yeah. Sigma by 4 epsilon a. So yeah, for today, yeah. Thank you everyone.